When 0.5 moles of aluminum reacts with 0.72 moles of iodine to form aluminum iodide, how many moles of the excess reactant will remain? How many moles of aluminum iodide will be formed? So our equation is aluminum plus iodine yields aluminum iodide. Iodine is diatomic, so we have I2. Aluminum is a +3, iodine is a -1, so we need 3 iodine to make this compound formula balanced. So now let's write what we are given. So we have 0.5 moles of aluminum and 0.72 moles of iodine. And we are starting with no aluminum iodide. So in the previous problems that we've been playing with, we were told which reactant was going to be used up, and we assumed the other one was in excess. Right now, we don't necessarily know when we're looking at the table. So if I start with aluminum and I decide, oh, we're not even balanced yet, so let's do that. So we have 2 iodine, 3 here. So multiply by 2, multiply by 3. Now we need 2 aluminum. All right, now we can move forward because we need our ratio of our moles to help us determine how much of each we would use. So if I start with the aluminum and I say, all right, all the aluminum is going to get used up, I'll subtract 0.5. The iodine is 1.5 times greater. There's a 3:2 ratio of iodine to aluminum. So I would take 3/2, multiply it by 0.5, that would give me 1.5. If I subtract this 1.5 from 0.72, I'm going to end up with a negative number. That's not possible. We can't use up more than what we actually have. So that means that the aluminum is not going to be the limiting reactant, that the iodine is actually going to be the limiting reactant. So that means I will subtract the 0.72, and the aluminum is a 2:3 ratio to iodine. So that means I take the 2/3, multiply it by the 0.72, and that gives us 0.48. So I'm subtracting this 0.48 because this is what we're using up. So we have 0.5, subtract the 0.48, it gives us a positive 0.02 left. 0.72 minus 0.72 gives us 0. Aluminum. Now how many moles of aluminum will we end up with? Well, we have a 2:2 ratio, so these are the same, so that means that we would gain 0.48 of product. So the aluminum was close to being used up, but it wasn't quite. So it asks us how many moles of excess reactant will remain. This would be 0.02. How many moles of aluminum iodide would be formed? This will be 0.48. So now you have 4, 5, and 6 to work through. These are a little bit different, just a tad different, where they're giving you the grams. So you will need to change your grams to your moles before you put it into your table and put your moles in your table. So your process is going to be the similar process to up here. You need to write down your equation, balance it. You need to then change your grams to moles. After you find your moles of each, put it into the table, determine which is going to be your limiting reactant and which is going to be your excess. So quite often when we see the excess, that's our limiting reactant, and sometimes I refer to the limiting reactant as LR. So in this particular problem, the aluminum was the excess and the iodine was the limiting reactant. So then answer your questions. Same with number 5, calculate the mass of water formed. So this is asking you to find the mass of the water, so it tells you what the end product is. This one asks you to calculate the mass of sodium sulfate. You will need your periodic table and your polyatomic ion sheet to complete these. Good luck!